Okay, now coming to this, a distributed hierarchical database. The last video you studied that the centralized DNS server will not be much helpful for us. So we are come across with a distributed hierarchical database. Now in this kind of DNS server, so there is no single DNS server concept. So instead of that, now DNS servers are distributed in several hierarchies. The first hierarchy, the top level hierarchy uh, of this DNS server, there are actually three classes we do in this DNS servers. In that, the topmost is the root DNS server, and the next one is the top level domain DNS servers, and the last one is authoritative DNS server. So these are three DNS servers. The first one is root DNS server, next one is top level DNS server, and the last one authoritative DNS server. Now, by taking an example, we will determine or we will understand how exactly this distributed or the hierarchical DNS servers is going to work. Now, let me take an example. I am going to get an IP address for www.amazon.com. So when I type it in a browser, now browser will send a query to this DNS server. So when this browser or the client, it will when it sends the query, the client first it will contact to the root server. This is the root server. See here in this diagram you can see this is the root server. This level, the top level is the root DNS server. The next level is the top level domain servers, and the next one is the authoritative servers. Okay, right. So now I am trying to find the IP address for www.amazon.com. Now in this case what will happen is that now the client will first communicate to this root server, which returns IP address from the TLD servers for the top level domain.com. Now the client now next it will communicate to this top level domain servers. Now this top level domain servers will be classified into something like .com servers, DNS server, .org servers, .edu servers. This is what top level domain is. Again under .com I have several things, yahoo.com, amazon.com and so on. Under this org DNS server I have pbs.org servers. Under this edu servers, I have poly.edu, umas.edu. So this is how the DNS servers will be differentiated under each top level domain servers. Now since I am searching for amazon.com, now this root DNS servers will route this to .com DNS servers. Now under this .com DNS servers, I'll find somehow I'll find this amazon.com server. Now this amazon.com server, now it will see what is the IP address. It will translate that host name into IP address. Now it will send the IP address to this top level domain. From top level domain it comes to root DNS servers. From root DNS server it will finally reach the client. Now this is how the hierarchical process is going to happen, right? So now coming to this root DNS servers. Now let me assume how many root DNS servers should be there. See, normally and earlier when it was this concept was come first, at that time there was only 13 root DNS servers were there. Maybe in the year of 2006, right? But even though we have only 13 root DNS servers, that was not sufficient actually. So now what we done, we replicated means the copy of these root DNS servers we have placed in several places. We are distributed in several places. That is how it has come up with a replicated servers. Now altogether in 2011 we add actually 247 root servers are there. Okay. Next, coming to the top level domain servers. Now, these servers are responsible for top level domains such as .com, .org, .net, .edu, .gu, and all. So that is why we have classified into the top level domains. And along with all this, we have the country top level domains, something like such as .uk, .fr. .uk means United Kingdom, .fr France, .in means India, and so on. Country level top level domains servers are also there, right? So based on the company also, we can create a top level domain. Now coming to authoritative DNS servers, here actually now every organization, if I take SRMVT, now I have an authorization DNS server with SRMVT.edu. Now for this SRMVT.edu, I have the IP address, right? So like this, we for all kind of organization or all kind of companies, we have the IP address for that particular host name, right? As I told you in the previous video that whenever I design it for whenever I create a website, for that website I have the URL that should be registered, okay, and during that registration of that URL I should also give the IP address for that URL, right? So this is one of the example it has been given how actually the DNS server will translate from host name to the IP address by flowing through the several hierarchy of the DNS, that is from root DNS server to the local DNS server, and how actually it will communicate from root DNS server to TLD DNS servers and so on. Now this is one of the hierarchy where I have I have my institute surmvt.edu. Surmvt.edu will maintain the local DNS server, right? Now this local DNS server will maintain almost all kind of database of all kind of websites. Now, if suppose this local DNS server is unable to retrieve the or translate the IP address, which is maybe it is very new to this local DNS server, this will now it will contact to the root DNS server, whether it will see whether root DNS server is having that or not, or it will send the host name to this root DNS server. Now, root DNS server in turn it will reply to the local DNS server. Now, this is the server IP. This is the server IP address you should communicate for the TLD DNS server. Now, it will send a query to the TLD DNS server. Now, TLD DNS server will tell, now this is the IP address you want to communicate to this IP DNS server. Now, again, local DNS server will again communicate to the authoritative DNS server. Now, finally, authoritative DNS server might give the IP address for this local DNS server. Now, this is one way, actually, how actually the hierarchical way or the distributed way the DNS servers will be located. Now, coming to the second way. Now, the second way is that now first being as a client and the client now it will give the I want to requesting for the IP for the IP address for this host name. It will first send to the local DNS server. From local DNS server, it will send to the root DNS server. From root DNS server, it will send to TLD DNS server. From TLD DNS server, it will go to authoritative DNS server. At the authoritative DNS server, I'll get the IP address. Now that IP address will be sent to TLD DNS server back, and that same IP address will be sent to read DNS server. From root DNS server, it will send to local DNS server, and finally from local DNS server, it will reach the client. Now this is how the process will happen in the translation of host name to DNS server. Now coming to the next concept that is called as DNS caching. As like we studied in last class what I mean by web caching, similarly what I mean by DNS caching is that suppose now whatever the client is requesting for an IP address, if suppose this local DNS server does not have that, right, where it will communicate to root DNS server. Next, it will communicate to TLD. Next, it will come to authoritative DNS server. Now, finally, I got the IP address. Now, once I get the IP address, now This IP address will be sent to this TLD, then it's sent to root, root will send to local. Now whatever the IP address is there, the copy of that IP address will should be maintained in a local DNS server. Now that means the copy of that will be stored in this database, and then this local DNS will send a IP address to this host, to this client. So this is what we call it as DNS caching. So that means the copy of that IP address is stored in this local DNS now. Now what happens is that might be due to some issue and all, maybe some website may change its IP address. Okay, so that may not be reflected in this local DNS server. Okay, so due to this, for for 2 days or 5 days or for every 1 week, this local DNS server, whatever the database it has maintained, that database will recheck by sending the host name to the root DNS server, TLD server, and then alternative DNS server, not to verify is this IP address is same, or is this same IP address is maintained for that particular host name. So this local DNS server should perform that operation at least for every 1 week. So this is also one concept of DNS caching.